introduction.
All right. Welcome, everybody. Thank you. My name is Girish. I'm a co-founder and CTO at PMX. Thanks for all joining. It's really lovely to be back here at RSNA this year. Anybody who has traveled from other places, I want to thank you personally because you've brought beautiful weather to Chicago. I'm sure some of you have come here a lot before. Snowy days, rainy days, but this is beautiful. So thanks a lot for doing that, and thanks for coming back again. So I'm here to share with you our journey. Specifically this year, we have sort of brought something a little bit more newer, broader, and created an integrated platform specifically for precision radiology here. I'll walk you through what that means and what that entails here. So one thing that really we've been all looking for, and I think there is a theme that's going on, is to make best practices in radiology much more accessible to the large community here, and make it such that it's not just this family, but it's a larger, broader audience that utilizes it in a more easier and fashion. So one analogy that really comes to our mind is in terms of automation being the best practice to be able to do that, in bringing automation and bringing all of these things together so that you can enable and deliver such interesting technologies to a larger audience. The analogy can be very nicely drawn from a parallel industry, the automotive industry, which is actually doing this autonomous vehicles, where you're starting to see vehicles that can fairly nicely, specifically the Tesla solutions, that actually can start to drive on its own. The vision, if you parallelize this to our industries, can we walk down the road to a CVS or a Walgreens and get ourselves scanned and get insights from those? And I think that's, I mean, it's a vision. It's sort of maybe a scientific vision or a very futuristic vision. But the idea is to simplify solutions such that you can actually take it there with multiple levels of automations that you can actually go through. So with that in mind, this is what we have created. This platform specifically is called MediOMX. Do not take this as a black or white, good or bad, evil versus good or something like that. I'm not trying to discriminate anything. Just two faces of our platform, simply two interfaces or two areas where we actually want to display and have people collaborate with us. The first side is the one where you have creators and collaborators. We want to invite people to come on and create these full end-to-end pipelines. We want them to be able to help us deliver those best practices to a larger audience in the world. And the second side of the platform is the users and the consumers, where anybody who wants to use this technology to be able to assess and help the patients and make the patients sort of be familiar with the entire process and what's going on with them, keep them engaged, and I think that's kind of what the second side. So what if there is a platform that can actually facilitate both ends and help and bring people together to create such fantastic end-to-end pipelines, as well as deliver them to the audience so that you can actually use them and make benefit out of that. So here is a simple workflow. It's something very familiar with most sort of people in this community here, going through the patients to the clinicians to the scanner, radiologists reporting it out and getting those radiology reports. Now, how do you envision what is an end-to-end philosophy here? And I think when we talk about end-to-end, would like to introduce the fact that, so first we start all the way from the scanning part. So we need to make sure that the acquisition is not something that's too complex. There are not too many dials, too many parameters to handle, too many variables to sort of make different imaging and image contrast sort of really span across the different sort of use cases. So why can't we optimize and create autonomous protocols that is almost just plug and play? Similarly, we also want to make sure that it's not just the protocols, but it also delivers really diagnostic quality, high quality images. From there, we go and derive clinical insights from these images so that these insights are easily palatable, helps make decisions faster, more confirmed diagnosis and stuff like that. And finally, create reports that are not only viewed and utilized by radiologists. Of course, radiologists are very familiar with these things and they actually do not need too much assist. but it is beyond the radiologist to say, either a neurologist or a pulmonologist, can they benefit from this data, not just have textual information, but visual information to be able to process it and make a better assessment. Not only clinicians, but even patients should be able to consume these reports and have better insights in what's going on in their body. So now, can we all plug this together into an autonomous pipeline? And this is the vision here, where we want to be able to create many such pipelines, whether it's for neurodiagnosis, lung pathologies, abdominal illness, and many such cases. This is why the integration of the collaborators and creators can create these autonomous pipelines, delivering these solutions to a large part of the world here. So I want to walk you through a simple use case of what we have done with this platform in order to create such autonomous pipelines. So here is a use case for dementia assessment, where it's a very nice, interesting paper a little while ago talking about an algorithmic approach of how you can actually take an individual through the dementia assessment pipeline. So it starts from MR acquisition here, looking at some certain specific signal changes that you can observe in various contrast images, observing any sort of atrophies or deviations from normality that may be observed in the pipeline. And then if none of these, then eventually declare that you are not abnormal, or for the age, everything is appropriate, and then reassess later. The algorithm basically, it's a very large decision tree process where the signal change goes through this decision tree, and then you look at hyperintensities, you look at microbleeds, and then arrive at final nodes of what variations of particular cognitive disorder that you might be facing, as well as in the cerebral atrophy, look at specific regions like the hippocampus and other regions where are known to be indicators of potential degradation of cognitive processes here. So now, if you want to pipe all of these things into an autonomous pipeline, how do you do that, right? So here is in the automation of protocol, what we've been able to achieve is, here is a standard brain imaging protocol with about a 12 minutes total acquisition. But what if, and this is what we've been able to show, the number of parameters that you are able to control is shown in the degrees of freedom here. And there are more than 40,000 and odd parameters if you put the permutations and combinations. And this is daunting. So we've been able to create the sort of a lookup table, and based on just simple one parameter of how much time do you have with the patient to image this thing. So you dial in the time, and the automated engine picks for you the most appropriate set of parameters to get all of these sequences done while maintaining the image quality. So one thing to keep in mind is, with AI, we're able to make some adjustments in post-processing, but the two specific parameters that's important here is contrast and signal. The contrast is something that's definitely not something we don't want to mess with, so that's an important piece of the puzzle. Signal we can retrieve, so we're able to compromise a little bit on the signal, but then retrieve that, which I'll show you in a little bit here. So now we have the acquisition done, but a lot of time and a lot of information is somehow missed, or the scans have to be repeated because of artifacts, movements, and just lack of sort of observance there. Just the pipeline of people to be imaged is high, throughput is very high, so it's quite natural for people to miss this. We have created a mechanism to do an inline detection of artifacts, where things like, for example, wraparound artifacts, Gibbs ringing, and motion artifacts can be detected while the scan is being performed in line, so that you can feed it back to the technologist while they are actually doing the scan, so that the patients do not have to be called back again, where the image becomes of lack of sort of proper quality use. And this saves a lot of time and definitely a lot of scanner utilization cost as well. Now, I mentioned about contrast, so we're not definitely compromising on contrast, but because of the rapid acquisition, we are compromising a little bit on the signal, but we can retrieve back the signal. Here is an example of a deep learning assisted denoising algorithm that takes the original standard scan, and here is a comparison. The second column is your faster acquisition, and after denoising, you can see that there is a difference. There is a significant drop because of the acceleration, but we can recreate and denoise the situations basically. So now we have created high quality, similar contrast, same signal kind of images, and the acquisition is fully complete here. Here is a good comparison here between, again, the gold standard, faster and faster acquisitions. As you can see, you can create very, very high quality images in a, this whole protocol takes like about 7.5 minutes to 10 minutes, and all of these sequences can be achieved with relevant diagnostic quality. Moving into the quantifications and clinical insights, there is a vast array of parameters that various indications use. Here is a list of different sort of indications and specific quantitative clinical insights and outcomes that can be generated from T1s, T2 flares, diffusions, T2 star, resting state fMRI, and all of these kind of stuff to be able to create an interesting pipeline. So a quick example of how an interactive report will look like. This is showing a simple HTML report that would be interpretable by most audiences, other clinicians, even patients, such that you can actually now see what are the different quantitative metrics that can be extracted from these the assessments that you have done. Lobes, specific quantitative information. These are relevant in making a longitudinal assessment of how the patient is progressing. We can now turn the place into the users and the other end of the spectrum, where we can actually deploy this in a mechanism that is, whether it's on-premise or on the cloud. This is fairly straightforward, where you drop this whole pipeline to the user and have the user basically just almost as a single push button operation. They want basically a dementia scan, and you hit the dementia scan, it goes all the way from setting up the protocol to doing these artifact assessments, clinical insights, and then the reporting all the way. And this can be done as the comfort of the client may be either on-premise or on the cloud. So in a similar manner, we have been able to not only create such, this was Brain as one example, but we've been able to create other pipelines like chest for CT and other body images for whole body. So it's a quick insight on another interesting example where we've done a similar use case for body, is to be able to use an athlete and make them go through an actual image and create sort of interesting insights about their functional dynamics, about their composition profiles, and this is being used to enhance the athlete's performance and to make sure they have a longevity in the game they're playing, or have injury-free sort of use cases here. And the coaches and the physicians are utilizing this to be able to do that. So in a sense, just another quick example of the actual report, which is able to show the functional movement that have been recorded by actual videos, overlaid on top of whole body MRI scans. So I want to basically sort of conclude by stating that we have a platform, and we want to invite people to join us to be able to create such full autonomous pipelines. We want to be able to deploy. We have the mechanisms to deploy it across a large audience. So help us create these pipelines. We will be able to plug in with our expertise and the platform, create complete pipelines from acquisition, the best protocols, to all the way to reporting, and then take this through whether the regulatory pipeline or required compliance pipelines, and deliver it to the audience that would be actually using it. Thank you very much.